For our next adventure, we're going to be rebuilding this power supply and making it better than it was before because we have the technology. This is a kit from WBAVGE, Mike Bryce. He has a website he calls the Heat Kit Shop, also Sunlight Energy Systems, and he sells this kit to rebuild the AC4 power supply for the Drake twin transmitter, which I believe is the T4XC, if I remember off the top of my head correctly, which is a transmitter that I own and is upstairs, so I'm going by memory. We'll see. So we have a pretty thick instruction guide, but it's mostly about retrofitting this new PC board, which is the power supply itself, which is going to be replacing all of the, or most of those components, if not all of them. And then it's not going to be replacing that big old transformer, but it will be replacing these old capacitors which have long since bit the dust. So I've had this kit for many years now and have never gotten around to building it. And now I'm basically getting around to it. Let's see how this goes. So the first step, of course, is going to be to build the PCB. PCB stands for printed circuit board. And the components here are not many, so the assembly of the board itself should go quickly, and it's the retrofitting in there which is going to be the fun part. So there'll be quite a bit of disassembly. I got to decide whether or not I'm going to take those old capacitors off or leave them in for show, although one of them will have to be removed because the hole will be needed to redirect some of the wiring from the transformer. So we'll see how that all goes. Hopefully I can salvage some of that, but maybe I can't. If not, it's not going to be a huge loss. Anyway, that's what we're here to do. So let's start with the PCB board. I'm going to put the camera down so I've got both hands to work with, and we'll go from there. So back in a moment. Okay, so we're going to jump right in here and follow the instructions. I did mention that I had this kit for several years. It's more than several, actually. And just to stress this, that this kit for the AC4R power supply is an older generation, and there is a newer generation available, and it is probably different than what you're going to see here. So just keep that in mind if you're watching this video and thinking about buying the kit, that I'm working with an older generation, and you need to check and see what the most current generation offers. So where's the start here? Assembly of the PCB. Position the PCB down so the caution high voltage is located on top. The bottom foil. Caution high voltage is up here. When installing the following diodes, be sure you have the banded end of the diode matching the silkscreen on the printed circuit board. That's good advice. I'm going to have to stop the camera because my eyes aren't what they used to be and I need glasses. I will be right back. Alrighty, we're back. We're installing the following diodes. The diodes will be installed first. The circuit uses all the same type of diodes, and they are all 1N5399 high voltage diodes rated at 1.5 amps. Matching diodes out to PCB, salt diodes, location, applications D1 through D7. So D1 starts there. The printing does alternate with these diodes, which we have to be careful of. There's D6, there's D5, and D7. Okay, so some people find building kits as boring as watching paint dry, but I have always enjoyed kit building. So, and I will show you what he's talking about. Hopefully this will show up and the lighting won't be completely awful. I think the lighting is going to be completely awful. You'll have to take my word for it. There's a little mark, there's a band, if you will, on the printed circuit board image, which indicates the band, the silver side, if you will, the silver banding on this side. And that's the way that we're orienting these diodes. So to put the diodes in, we're going to just gently push over the leads like that. And again, make sure that the band on the diode matches the band on the printed circuit board. And we're going to turn this over and splay these leads out a little bit so that the diode stays in place. And for the next one, same thing. We turn the leads over with a gentle push. Let it find its own natural curve. The silver side is in the right orientation to the board, and we pull it through, and then we spread the leads like so. And then the next one, just gently push them over with our hand. There's no need to use tools here at this point. Splay them out again. Keep the components in their spot. And match the band. Splay them out. And now we have 3 more. There's D6. You also, just for aesthetic purposes, you want the component as close to centered between the image as you can get it. This one's not quite centered. Let's take that out. Adjust the bend a little bit. There, I like that better. One more, and D7. to solder up these diodes using my handy dandy Weller soldering iron. Non-adjustable, model WTCPT. So I can't adjust the heat, but it hasn't caused me a problem before, so I'm not going in any really set planned strategy of an order. I'm just going by eye, what's convenient. You don't need a huge amount of solder. But you do need to make sure that you've got a good solder connection. So it doesn't need to be a huge blob, but it does need to be sufficiently heated so that there's a good bond between the printed circuit board and the component. And you'll see that flow. Another tip-off is if the solder is shiny, when you take the solder gun, or solder iron I should say, off it, and once the solder cools a bit, if the solder stays shiny and it's not dull, then that is a good solder. If it is dull, then the chances are you have a cold solder joint and you need to reheat it and maybe dab just a little bit extra solder on it to make sure you've got a really good connection. So as you see, I don't need to hold the soldering iron on to the component for a very long time in order to get both the wire and the printed board sufficiently hot to melt the solder. And in some cases, you can't dawdle, so to speak, on a connection because the component may be very sensitive to heat, and you will want to do your solder work and remove the heat as quickly as you can. While still making a good solder connection. And usually when you're building a kit, you should, a good set of instructions, I should say, will warn you that you need to be careful about overheating a component. Okay, now after we're done, before I do any snipping, I'm inspecting my solder connections to make sure that they're good, making sure, turning it over, making sure that the parts haven't shifted or lifted up off the board, because unless the instructions specifically call for a part to be not flush against the board, then you want them flush, again, mostly for aesthetic purposes, but sometimes, particularly for boards that have RF componentry, the positioning of components can be very important. So let me see if I can zoom in here. Come on. Are you going to focus? Come on, focus. Oh, it's too close. So those are those components, and then here are the other diodes, and I turn the board over. This is so funky to try and get the board positioned right with the camera. There you can see the leads all soldered up. And that is successful in my view. So let's zoom out a little bit. Maybe that's maybe there. No, there's a danger that I'm going to go up there. We'll leave it there. So we have our diodes in. Now I'm going to use a pair of oversized wire clippers, which are not recommended or ideal, to cut these leads off, and it's only because my proper set is in my car and it's 10 o'clock at night and I don't want to be bothered going out to the car to dig out the proper set of wire cutters. These big wire dikes are doing the job just fine, as you can see. You do want to be a little bit careful because with smaller wire cutters there can be a tendency for these leads to kind of spring or pop off. A little bit of ejection kind of an action going on, and you definitely don't want to get poked in the eye with one of those leads. Okay, so we have all of our diodes installed. And what's next? When installing the following resistors, mount them so they are a 1/4 inch above the PCB. Aha! So, just as I was saying before. The metal standoffs make good spacers. He's referring to these things. So we'll use one of them as a spacer. Install 3 150K ohm resistors, brown, green, yellow. For those of you who are completely uninitiated, resistors are banded, and those bands count as a value. So you can look up their colors on a standard chart and determine what the value of a resistor is just by looking at the bands. However, there is a subgroup of our population who have issues with color. And I am one of those people. I'm colorblind in red and green, and what that means is that I generally have challenges with colors, and so I have to use an ohm meter to make sure that I've got the right value resistors before I install them. And according to my ohm meter, that's 104, 109 point something ohms, and I'm sorry, I said 149. This is 148, 149 exactly, and this one is 149.6, or what's that? Well, whatever. Okay, so they're definitely 150 ohms. And actually, I just want to double check that the K indicator came up, and it does say K ohms, 148.9. Okay, so set the ohm meter aside. We have our resistors, and install 3 150K resistors, brown, yellow, green, yellow. And it is the green that I can't see properly. And as crazy as it may sound, the second band is supposed to be green, and to me it looks gray. Go figure. I don't know if you can see that with the lighting. Probably not. I may stop at some point and just double check this because it is at night. I have overhead lighting, and then I have this lamp right here, and double check and make sure that the lighting isn't awful, because that has been a problem in the past. So I think maybe I'll do that right after I install these 3 resistors. So it's R1, R2, and R4. R1, R2, and R4. So once again, we want to gently bend over the leads with our finger. No need to use a pair of needle nose pliers or anything like that. This should be good. And again, there's no right or wrong way of orientation. However, typically I believe you would read the bands left to right. So the band on the far right is usually the tolerance factor. In this case, the gold band. I believe is that 5%? It's either 5 or 10%. I think it's 5%. So we are going to install these resistors, and I'm going to temporarily put them flush just so that the leads are properly positioned left and right. And then I'm going to use this standoff just as they suggest, and then I'm going to splay out the leads on the reverse side. Now, for the uninitiated, you might be wondering, why the heck are you mounting these particular resistors off the board? And most likely, the reason is because these resistors are large and they are going to be generating a lot of heat. So this will allow air to circulate around the resistor on all sides. Resistors are not usually heat sensitive components, so I don't have to worry a whole lot. I wouldn't just leave the soldering iron here to bake onto the resistor, but there you have it. The resistor is standing properly. And in this particular case, I will snip off the leads on each component as I solder it, unless there's a compelling reason not to do that. Also, just for aesthetics, I'm making sure that everything is centered and whatever, so this looks like a neat, professional kit build. Again, I'm pushing these all the way down just to make sure that the resistor is oriented properly, and then pulling it back up to put the spacer underneath. And what I'm checking for here is to make sure that the resistor is not cockeyed to the left or right, and then I am splaying out the leads so that the resistor can't fall through. And notice it didn't. The spacer came out, but the resistor stayed in, and that's because I was pushing the leads away so they could not go easily back through the holes. That's why we do that. Oops. And am I? Again, I'm looking for solder flow, the component lead, and the pad on the printed circuit board. Also, after each time I solder, I am wiping my soldering iron clean and inspecting the solder to make sure that it looks good. Now here, meh, I think one side is sticking out a little bit. Now you get to see my OCD in action. I like that better. You don't have to do that. Again, I'm looking for aesthetic quality here. Totally up to you as to whether or not you want to do that. You could just leave it and there would be no harm, no foul. Like that. And again, left to right with the gold band at the right, left to right with the gold band at the right, and last resistor. And we're going to do the same thing. Gold band to the right. And again, doesn't have to be to the right, but I mean, it's the electronics will work either way, but it's oops, I forgot to lift it up. Okay. I should mention here that there's another reason why you want to inspect your solder joints, and that is because many modern kits have foil that runs on both sides of the printed circuit board, and this is a good example of that. So when I'm soldering, I want to make sure not only do I have a good solder connection on the bottom, this is actually the bottom, and this is the printed side is the top, quote unquote. I want to make sure that the solder has flowed through the PCB to the top when I know that there is a dual connection here. And I'd say that this looks good. And now we can, where are we here? Take our oversized cutters. And that looks good to me. Where are we here? Does it look good to you? Hopefully you're saying yes. You're nodding. I wouldn't blame you if you were nodding off. This build should go quickly. It's the assembly that's going to take a while. The capacitors will be installed next. It is very important that the capacitors be installed correctly. If you put one in backwards, be ready for lots of smoke when you first apply power to the PCB. Duly noted. Hint: when finished with capacitors, all the negative leads go the same way. They all point towards the bottom edge of the board. Install two 125 microfarad 450 volt capacitors at locations C1 and C2. So, two. Well, that's not it. All these components, the capacitors are printed, they're marked, they're not banded. And so we just have to look on the side to see which ones that the instructions are talking about. Must be these big jobs. One. Those are 150. 100. I think I remember something about this. I think it's really the 100s. I think that 125 is a typo. $150. And one side, as you can see, has got minuses printed on the side, and there's a plus on the printed circuit board, so we know that the minus does not go in the plus, so we want the minus to the minus and the plus to the plus. So, what was that beeping? Not sure what that beeping was, but it didn't sound friendly. Let's get these capacitors installed. Now here I'm going to do something a little bit different. I haven't splayed out the contacts here because they're so short. I'm not going to solder both in just yet. Oh, I know what that beeping was. That was my ohm meter turning itself off. Good night, ohm meter. I'm only soldering one post to make sure that the component is flush up against the printed circuit board. Whoa. And that one is. And that one is too. Now the components will stay in place so that I can solder the other leg with confidence, and that these caps, capacitors, are flush and straight. Okay, let's see how we did. I don't like that. That one's crooked. Okay, I like that. And so we have our two towers of capacitance installed, like so. Where are we next? Install 3 100 microfarad 350 volt capacitors in locations C3, C4, and C5. So I think it's these 350 volts, 100. And there's our minus signs. So we want to make sure that we're not orienting the minus to go through the plus. Also, take a note of something. Do you see the leads? See the one is shorter than the other? Typically, the shorter lead is minus on these types of components. And here, can tilt these leads out a bit. And again, I'm only going to solder one end to make sure that it's in there flush and straight before I solder the other. Even though, as you saw, it's not a tragedy if you have to heat up a lead to get the aesthetics right. But, of course, if the component is really heat sensitive, that would not be the best solution. That angle was a little bit too steep for soldering, so let's prop the board up a little bit. Okay. Straight. There was C3. It was C4. Now I'm going to do C5 and C3. Let's do C3 again. Negative side, also the shorter lead. So the longer lead, the positive lead, goes through where the PC board says positive. Anything here? Maybe this. No. I'll just have to reheat here. I don't want to have to reheat every single pad. It's not really... It's not optimal. One and done and all that. And it's not completely flush. Okay. And again, I'm doing that for aesthetics. So if you think I'm being too anal, you can say so if you want. But it's my kit, and I can build it the way I want to, right? Let's these posts as well. And C5 is next. There's the minus, there's the long lead, there's the plus sign on the board. Okay. Install two 47 microfarad 350 volt capacitors. These are the 47s. C7 and C8. There's C7, there's C7, and there's C8. And again, we have minuses, we have a short lead. The long lead goes through the positive. I think this one is staying in position, so we'll take a chance. And solder both leads at the same time, and indeed it is flush and oriented properly. C8. There's your minus sign. Your long lead goes through plus. Out of the picture. God damn it. Sorry about that. Even if it was the top of the picture, hopefully you were still getting to see what I was doing. It's the one thing about doing this kind of work with a video camera, keeping it oriented properly. So there you have it. Now, only a couple more components. And I must have skipped over something because I'm missing two. These resistors here. Or am I done? No, there's R6, there's R5, and R3, A, and B. So where are they? Install, I skipped over a step. Install the 200 ohm red, black, brown resistors, locations 3A and 3B. Be sure you have these resistors mounted at least a 1/4 inch above the PCB. So, I'm going to assume that these big suckers are the 5 watters and measure them. So let's bring our ohm meter back into the picture. And we're looking for 200 ohms. 2. And we'll check this one just for yucks and giggles. 208, according to the meter. This time we'll turn the meter off. Okay, install the two 200 ohm resistors at R3, A, and B. Excuse me. Is it a gold band or silver band? Can't quite tell. I think it's gold. Okay, so R3A and B are here. Come on, let's move the camera instead. Is that better? Because that's where I'm working. Okay, so R3, let's do R3B first. And again, I'm going to push. Well, I can't do that this time because the leads are. What would I? What you can see here, and I'll show you the way that the printed circuit board is cut. The leads are being forced inward. There's nothing in there about these holes on the outside versus the inside, so I'm going to assume that it's the holes on the inside where these resistor wires go. And then it says make sure it's 1/4 inch above the PCB. So I'm going to do it like that. Okay, I think we're going to solder up one side first and check the orientation before we solder up the two. Now this looks like the foil goes through the printed circuit board to the top, so we're making sure that there's enough solder to get through the hole. Now, for these oriented, if you will, up-down, should the bands be on top or should the foil be on top? I wasn't paying attention to that, so probably the band should be on top so it reads top-down. I mean, these three bands should be oriented on the top, but I've already soldered one end, and as I said before, it's not critical which is which. Somebody may smirk at my amateurish soldering of these two resistors in the quote-unquote wrong way, but I can take the criticism. Okay, let's make sure the solder has made it all the way through. I want a little bit more solder on the opposite side of the board. On that end, yeah, I like that better. Nice, solid electrical connection. So let's cut these leads off with my oversized dikes. And again, since we put the gold band in that orientation, well, we could say if we look at the board this way, it reads left to right. So maybe we're not completely wrong here. And again, let's put these on the inside holes. So those outside holes probably are destined for a wire. And we'll use our standoff here. And once again, I'm going to solder only one of the two leads in case I don't like the orientation. Just making sure that the solder has flowed. The solder on this side of the board seems a little bit shallow, which tells me that it has flowed to the other side of the board. And indeed it has. It looks really good. Like so. Yes. I hope you can see that. Okay, we have two more resistors and then we are done with the PC board. Okay, they're both 2-watt resistors. They're different values, so we have to be careful. 10K ohm, blue, brown, black, orange. Let's see if we can pick out which one is which. Orange should be the tell, because I can see orange. I see orange. We're still going to measure it just to be safe. I've gotten into that habit because of my color challenges. So this should be a 10K ohm resistor. So we get our measuring device out again. And it should be reasonably close to 10K. So we're looking for that little K symbol, and it's 9.91. Okay, so 9.91 is acceptable, and that goes in R6. So I'll turn these contacts over. R6 is here, and the print is oriented this way, so left to right, I think, should be the way the print is oriented on the board. Hold that down, tip them over, and we'll do one at a time. One resistor at a time, that is. Here I think we can solder both leads at once. And that looks good. So this other resistor should be 6.8K, blue, gray, red. I see blue, gray, but remember, that gray looks, to me, there's no difference between that gray and the other gray, which was actually green. So let's measure this to be safe. We're looking for 6.8K. So any of you colorblind people out there watching kit construction, there is hope for you. 6.8K. That was 6.63K on the meter. How accurate that meter is, though, is it's not an electronics bench meter, so it's probably not as accurate as I probably should be using, but it's good enough to give me the right idea. Okay, so left to right, left to right. Okay, let's solder this up, and then this board will be done. Another thing that I'm looking for when I solder these, for these printed circuit boards that are double foiled on both sides, these pads that go straight through, I'm looking for the solder to kind of seep in, if you will. That tells me that the solder is flowing from one side of the board to the other, making a good connection on both sides of the board. And then when I look over, I'm looking to see that there's solder on this side of the board. That indicates that I've got a good electrical connection. So I think that this pretty simple assembly of this board is complete at this point. And we're good to go for the next phase. So that's the board assembly. Now the trick is going to be all of these wires. And the one thing that really concerns me is the notes in the instructions, which talk about the fact that the wires, the coloration of the wires that the kit builder or kit creator is talking about warns that the colors might not be the same because of variations in the manufacturing process for the power supply, which is worrisome because of my color challenges. So we'll see how that goes. Anyway, so I hope you enjoyed this simple build, or at least to my view a simple build, and I will rejoin you in due course once I understand what needs to come off and apart from the power supply itself to make room for this board and figure out the wiring. So I will record that as well, but I want to kind of get an understanding of what all these wires are and what I need to cut out. I probably will do the removal of componentry off camera. We'll see. Anyway, thanks for watching so far, and more to come. See ya. Bye.